Hello guys, Doing Zealous here, and today we're continuing Krypton. Ready for that? Krypton difluoride. On March 23rd, 1962, British chemist Neil Bartlett created the first true noble gas compound. He combined xenon and gaseous spontaneum hexafluoride. PTF6, which reacted instantly to produce a yellow-orange solid. That solid was the first proof that noble gases could indeed form compounds. Bartlett's discovery quickly inspired attempts to form other noble gas compounds. In 1963, Dr. Mackenzie created the first krypton compound when he indurated krypton and fluoride. And then fluorine. Just go check out that video, the fluorine series. Fluorine part 1 to 4. F, an electron beam at negative 238 degrees Fahrenheit, negative 150 degrees Celsius. He produced krypton difluoride, KrF2, a white crystalline solid. Krypton difluoride is still the easiest krypton compound to make and the most common one. Krypton difluoride's most important use comes from the fact that it is a powerful fluorinating agent, a substance that transfers fluorine to another material. This property has enabled the compound to remove platinum. The atoms in krypton difluoride are arranged in a straight line: fluorine, krypton, fluorine. The krypton atom, with its atomic number of 36, is much larger than the fluorine atoms, whose atomic number is 9. Platinum combination from inside equipment at Los Alamos National Laboratory. Alamos. Krypton difluoride reacts with the radioactive plutonium to form plutonium. Hexafluoride. Hexafluoride, PuF6, which is a fairly stable gas and therefore easier to deal with than sulfide platinum. Some scientists have suggested krypton difluoride could be used in a similar way to remove uranium combination from equipment. Although krypton difluoride is useful, it must be handled carefully because it's such a powerful oxidizer. It reacts violently with skin, water, and organic matter. Scientists using the compound must be careful to avoid contact with it. Los Alamos National Laboratory, located in New Mexico, is part of the U.S. Department of Energy. It conducts research involving the application of science and technology to matters of national security. Krypton uranium compound. In 22, scientists at Ohio State University and the University of Virginia announced the discovery that uranium could form compounds of free noble gases. Krypton argon, and xenon. As often happens with scientific research, the discovery came about by accident. The scientists were studying CuO, a compound of uranium and carbon dioxide. CO. Also, carbon dioxide is also a really dangerous thing. They want to learn how radioactive metals react with small molecules such as those of carbon dioxide, which is also really poisonous. For their research, they formed collaborates with noble gas molecules acting as host molecules for CuO. To their surprise, they found the noble gases are forming compounds of uranium atoms in the CuO. The scientists were so astonished they couldn't believe the results at first. However, continued testing confirmed the discovery. The scientists say this may open the door to further research. The same technique might be used to form compounds of noble gases and other metals, perhaps more important. The scientists say the results provide a new window on how chemical bonds can form. New understanding of how chemical bonds form can expand our knowledge of chemistry as a whole. Compounds of noble gases and hydrocarbons. In 2005, aka 3 years after 2002, where they discovered uranium could form compounds of the noble gases. Scientists in Finland and Russia announced that they have produced compounds of noble gases and hydrocarbons. Many scientists see this as a significant development. Hydrocarbons are simple organic molecules, incorporating only hydrogen and carbon. The enormous energy contained in hydrocarbons makes them very important to modern life. Hydrocarbons are found in crude oil and fuels made from it, such as gasoline, diesel fuel, propane, and butane. Hydrocarbons also pose many risks. They can help create ground ozone, which is a serious air pollutant that can cause breathing problems and lung damage. That's a lot of damage. When hydrocarbons are burned as fuel, they generate carbon dioxide, a widely recognized greenhouse gas that is produced through global warming. I don't think we can fix that because what we breathe out is carbon dioxide. Hydrocarbons can also cause cancer. Some scientists believe further research into hydrocarbon, and noble gas compounds may yield important new life-improving products. For example, new accidentic compounds might result. In addition, the hydrocarbon and noble gases compounds may lead to new fuels that are more energy efficient and create less pollution. Creating fusion? Scientists have long tried to produce energy by fusion. Fusion is what powers the sun. It is the energy released when two hydrogen isotopes are fused or combined. Fusion has many advantages over fission. Unlike fission, its products are not radioactive. It reacts, Hydrogen isotopes are abundant on Earth and can provide energy for millions of years. Some scientists are experimenting with using special lasers, including krypton fluoride. KRF lasers produce fusion. In a krypton fluoride laser, electric current passes through a gas containing krypton and fluorine, producing a concentrated beam of light. Multiple parallel krypton fluoride lasers are used in efforts to create fusion. Chapter 5 Krypton and You. We have already looked at some of the uses of krypton and krypton difluoride. However, those uses are not as part of everyday lives of most people. So by the time you may thinking that krypton does not have much to do with your daily life, it may surprise you to learn that krypton is used in some objects that are so common. We rarely think about them. Krypton and light bulbs. Light bulbs are so familiar, we take them for granted. There are different types of light bulbs, but most people use incandescent light bulbs at home. This type of light bulb has a thin tungsten W filament inside a glass globe. When electricity runs through the filament, it produces heat and light. Because the heat could cause a fire if there were oxygen inside the bulb, air is sucked out before the bulbs are sealed. However, this creates another problem. The heat causes tungsten atoms to break free from the filament. Without any gas in the bulb to slow or stop the tungsten atoms, the filament disintegrates, giving the bulb a short life. Since noble gases do not pose a fire risk, they are put inside the bulb to slow filament disintegration. Some tungsten atoms bounce off the noble gas atoms to return to the filament, making the bulb last longer. Low-cost argon is used to make most incandescent krypton, incandescent bulbs. More expensive krypton, however, is used in high-priced bulbs because more massive atoms bounce more tungsten atoms back to the filament. This makes the filament last longer and allows it to be heated more, so it is brighter. Incandescent bulbs waste a lot of energy producing heat instead of light. Nevertheless, people like them because the light has a lot of red in it and seems more like sunlight than a bluish light from more efficient fluorescent bulbs. They also are simpler and less expensive to manufacture. Fluorescent light and neon signs. Fluorescent bulbs work differently than incandescent bulbs. Fluorescent bulbs work differently than incandescent bulbs. A fluorescent bulb contains a noble gas and a small amount of mercury. Hg. Phosphorus coated inside the bulb. Phosphorus coats inside the bulb. When electricity flows through the bulb, the ionized gas creates an electric arc that changes some of the mercury into gas. Some of the mercury gas atoms become excited. That is, some of their electrons get bumped to higher energy levels. When these electrons drop back to the normal energy level, they give off an ultraviolet light. People could not see the ultraviolet light. However, it excites the atoms of the phosphorus. It is hard to imagine the commercial districts of the world cities without neon lights that light up at night. This photograph shows This photograph shows the shopping district at downtown Seoul, South Korea. I think I meant to put the for photograph shows. Photography. However, it sights out on the phosphors on the inside of the bulb. They give off light people can see. The NOAA gas that is key to this whole process is usually argon. Sometimes, however, krypton is added to make the light brighter. NOAA gases are used in the familiar neon signs we see on many businesses. When electricity is sent through the signs, glass tubes, it makes the gases glow. Different gases glow with different colors. Neon, which gives name to these line signs, produces an orange-red color. Krypton gives us a greenish-yellow color. Xenon produces a blue, and argon gives off a light bluish purple. Let me start for that. And that's it for today's video. Hope you guys enjoyed. And I'll see you again very, very soon. Later.